For today's video, I will teach you how to identify the domain and range of a function. But before that, let us have a short review about interval notation and set builder notation, since these two notations will be used in identifying your domain and range or in stating your domain and range. So let us start with the interval notation. For your interval notation, always remember that if you have these symbols greater than equal to and less than equal to on your graph, you will use solid circle, and in stating your interval notation, you will use square brackets. Square brackets indicate that you wanted to include the value on your set. And if you have these symbols greater than or less than without the equal sign, meaning to say it is not included, certain value is not included, you will use hollow circle or parentheses. So let's have an example using the number line. For example, we have this number line and this is negative 5 going to positive infinity and this is negative infinity. So let's say your graph looks like this. So from negative 5, you have a hollow circle going to positive infinity. So in here, your notation would be, since we are on a hollow circle, meaning to say you need to use parentheses. So beside negative 5, you will use parentheses to indicate that negative 5 is not included on your set. Then as you can see, your graph goes to positive infinity. So to state it here, it would be negative 5 going to positive infinity. But then, if you will have this type of graph, let's use similar values. Let's say we have negative 5 until positive infinity, but then we will use solid circle instead, going to positive infinity. So in here, to state your interval notation, you will now use the square bracket to indicate that negative 5 is included because the symbol here is either of these two. Then going to positive infinity. Take note that if you have positive infinity and negative infinity, beside it is always a parenthesis. So if you will be given two values now, let's say we have negative 4 and positive 5. And your graph looks like this. So one is hollow, one is solid. Then we connect it here. So for your interval notation, since this is hollow, we will use parentheses. Then this is negative 4, then 5, then square bracket because this is hollow. Meaning to say negative 4 is not included on your graph or on your set, but 5 is included. Another example would be this one. So let's say this is negative 6 to positive 7. So this is hollow. This is solid rather. This is hollow. Then we connect it here. So we use square bracket here. This is negative 6. Then until 7. Then parentheses. Let's have other examples. If in case your graph looks like this one, we split the graph into here. So we know that this is negative infinity and this is positive infinity. We will make two separate interval notation for this one. So in here, this would be negative infinity until negative 2, but then you will use parentheses since we used hollow circle here. Then in here, this would be 5 going to positive infinity. We will use parentheses also since this is hollow circle. Then we write union. Meaning, if you have the union of these two intervals, we won't include the values on the middle on this part. Okay, next example. Let's say this is negative 6 until 8, positive 8. And your graph looks like this. So in here, so this is negative infinity, this is positive infinity, so we will use parentheses, then negative 6, square bracket because this is hollow. Union of, then parentheses since this is hollow, then 8 going to positive infinity. So that is how you identify the interval notation. For the set builder notation, the commonly used symbols would be like this. So this one is read as x such that x. This would be read as y such that y. This symbol is read as is an element of, and this symbol is real numbers. So these are the widely used symbols in set builder notation. So let me give you an example of a set builder notation. So we can have x such that x is an element of all real numbers. We can have x such that x is greater than or equal to 5. Also, we can have x such that x is greater than 6 but less than 8. So in here, the reason why I read this as greater because it's facing x. X is greater than 6, 6 is less than x. So x is greater than 6 but x is less than 8. So these are examples of set builder notation. Let us now proceed with your topic, which would be all about identifying the domain and range of a function. On your first example, what we have here is f of x is equal to 2x plus 1. So in here, we have a linear function. When we say linear function, the highest degree here is 1, or the highest exponent that you can see on your variable is 1. So before we identify the domain and range, always remember that when we say domain, those are all the values of x, or all of the values that you can plug in on your variable x. And when we say y, that is the output. Also, that would be the outcome when you plug in certain values on your x. And always remember, f of x is equal to y. Y is also f of x and f of x is also y. So let us now identify the domain for this example. So in here, as you can see, you can just substitute any values on your x. May it be positive, may it be 0, may it be negative, meaning you don't have any restrictions. So in here, we can identify that your domain is all real numbers. In interval notation, it would be negative infinity to positive infinity. When you use the interval notation for the set builder notation, so you can have any of these two as your answer. So in set builder notation, it can be x such that x is an element of all real numbers. For your range, as you can see, you can have any possible answers here, any possible outcomes. You can have negative values, you can have 0, you can have positive values, meaning your range would be y such that y is an element of all real numbers in set builder notation, or if you would like to use the interval notation, it can be from negative infinity to positive infinity. Let us have the second example. For your example here, as you can see, we have 3x squared, or f of x is equal to 3x squared minus 2. So in here, we will have restrictions. It's because that in here, you have a quadratic function. When we say quadratic function, your graph here is a parabola. And we know that the graph of parabola can either be like this one, or like this one. So if you have the upward parabola, meaning you won't have any values on below of the vertex. If you have this type of parabola, you won't have these values or the above values on your vertex. So let me erase those first. So let us identify the value of your domain here. So in here, your domain, you can just plug in any values. You can have negative values, you can have zero, you can have positive. So your domain would be from negative infinity to positive infinity on interval notation or x such that x is an element of all real numbers. We will have a problem here in identifying the range since your exponent here is even number, meaning if you substitute negative number here, it becomes positive again. Let's say negative 1 squared is just 1 times 3 minus 2. It will have the same answer as positive 1 squared times 3 minus 2. So how do we identify the range for this one? What you're going to do is to use the inverse function of the given. So we will replace f of x as y. Then we copy 3x squared minus 2. Then we will change all of the values of y into x and all x into y. So this would be x is equal to 3y squared minus 2. Then we will solve for the value of y. This will be x plus 2. So negative 2 becomes positive 2 on the other side. Then this would be 3y squared. Then we divide both sides by 3 to cancel this out. What remains would be y squared is equal to x plus 2 over 3. To get rid of squared here, what you're going to do is to get the square root of both sides. So y is equal to square root of x plus 2 over 3. So as you can see, you can now identify the restrictions. Since the value of y would be square root of x plus 2 over 3, you just need to identify which values are not allowed inside your radical sign. So in this case, negative values should not be allowed inside your radical here. We can use positive 3 since 3 plus 2 is positive 5 over 3. There's no problem with it since it's positive. If we use positive 2, it would be 4 over 3. If we use negative 2, so negative 2 plus 2 is 0, 0 over 3 is 0, that's also allowed since the square root of 0 is just 0. But then, if we will use negative 3 on this part, so let's say x is equal to negative 3, like for example. So this would be negative 3 plus 2 over 3. And that would be equal to square root of negative 1 over 3. Since this is positive, we can no longer use this one. So meaning, the only outcome that you will have here would be um, y such that y is greater than or equal to negative 2. Any number that would be lower than negative 2 would not be an answer here. So for your range, we can identify this one as, so from negative 2, as negative 2 is included, we will use square bracket to positive infinity. So this is now your range and this is your domain. So as you can see, we can plug in any number for your domain, but then all the possible answers would be from negative 2 to positive infinity only. Let us now have your next example, example number 3. So in here we have f of x is equal to x cubed plus 2x squared minus 5. So don't be afraid that you have higher degrees here. Always remember that if you have the highest degree as an odd number, your domain and range here would be like this one. So your domain would be any real numbers. So from negative infinity to positive infinity only. Same goes for your range. It's from negative infinity to positive infinity. Just look on the highest exponent on your function. If it's odd, then the domain and range, there is no any restrictions. Next example. On your next example, we have f of x is equal to x squared all over x squared plus 1. So in here, the only restriction should be your denominator should not be equal to 0. Because if in case that your denominator becomes 0, it is undefined. And undefined values is not allowed in mathematics. So in here, um, since we can plug in any number on your denominator, since this is plus, meaning to say there is no other way for you to have 0 on your denominator. So on your domain, we can plug in any number. So domain here would be negative infinity to positive infinity. And your range would be from 0 to positive infinity, including 0. Why 0? It's because if you plug in 0 here, you will have 0 over 1, and that is equal to 0. If you plug in positive 1, your answer is all positive. If you plug in any negative numbers, your answer would always be positive since we square it. Any number that we square, even if it's negative, it becomes positive also. So for this example, your domain is negative infinity to positive infinity, and your range is from 0, including 0, to positive infinity. Let's have the next example. On your next example, we have here x squared all over x squared minus 1. In here, we will have restrictions. It's because we can still factor out this one. So this can be x squared over x plus 1 times x minus 1. And if you plug in negative 1 here, this part becomes 0. Then if you multiply this 2, it's 0 because any number multiplied by 0 is 0. So to identify the domain, the first thing that you have to do is to identify which value should not be included. So in here, we will equate x squared minus 1 into 0. It should not be equal to 0. Then x squared is equal to, or should not be equal to positive 1. We get the square root of both sides. So x should not be equal to positive 1 and negative 1. When you are looking for a square root of a number, there is always two answers. It's positive and the negative root. So in here, we can plug in any number on your function except positive 1 and negative 1. Because if in case that you plug in positive 1 or negative 1, your denominator will be 0. So for your domain, so let's use the set builder notation first. So x such that x is an element of all real numbers and x should not be equal to positive 1 and negative 1. For your interval notation, so in here, it should be like this one. So we have here negative 1, then positive 1. Then we will graph them. So for negative 1, since negative 1 is not included, we will use hollow circle, then going to negative infinity. Then for your positive 1, same goes for it. It's hollow circle, but then you're going to positive infinity. So we will identify each of them here. And also, this part is also included. So in here, This is negative infinity to negative 1, then parentheses. This is negative 1 to positive 1, parentheses. And this is positive 1 to positive infinity. So, to write your interval notation, we will just simply write this one. So, from negative infinity to negative 1, union of positive 1 to positive infinity. So meaning, the only values that is not included would be negative 1 and positive 1. Let us now identify the value of your range. So to identify the value of your range on your given function, if you substitute 2, this would be 4/3 only. So that's positive. It's negative. Still, you will have positive number. But then, if you use 0, that's the time that you will have 0 only. So meaning, you will have an answer from 0 to positive infinity only. There is no other way for you to get any negative numbers. So for your range, this would be including 0 to positive infinity in interval notation. For set builder notation, that would be y such that y is greater than or equal to 0. I will end the video here. So this would be the part 1 of identifying domain and range of a function. On your second part, I will give additional examples on the domain and range of rational functions and also functions involving radicals. So hopefully you learn from me. Please don't forget to subscribe. Click the bell button for you to be able to be notified whenever I upload videos. So once again, that is our Math Minute. Thank you and God bless.